For this assertion, we'll track the progress of an entire AXI write transaction. We start by opening a Visual SVA window and look for the beginning of the transaction with AW valid and AW ready. Once this occurs, we first need to use our action boxes to capture some information. We'll first capture the value of the AWID signal into the variable AWID, and next we'll set a variable called wCount to the value of AWLen, so we know how many write transactions to look for. Next, we'll wait for individual transactions on the write data bus. And here we use our local variable to make sure that the correct ID is seen. Every time there is a data beat, we now want to decrement our wCount variable. And of course, for reverse, we need a repeat, so we'll use the repeat operator. And we'll repeat between 0 and 3 times. For a full AXI, that would be 0 to 15, but we're going to keep our example short. The next thing we want to do is look for the last data beat, which is wvalid and wready and wlast. And at this point, we also want to check that the proper number of data beats is seen. So we check to see wCount equals 0 at that point. And the final thing we will do is look for our write response. And in this case, we also want to put an extra check to say that we expect our V response to occur within 10 clock cycles of the last data transfer. And we can look at the code view of this. See, that's a fairly complex transaction. Next, let's run a simulation. And speaking of that, we will actually just run a single frame. We'll clean up our stuff. See our assertion starting here with a transfer length of 3 and ID of A. If we look at our transactions, there's the first data beat, the second, third, and fourth data beat, and we see our responses here on the same cycle as the last one. Notice, however, that we did not qualify the last signal. So the AW last actually fires in both of these cycles as well as the last one, so it shows us that we need to clean up our assertion some more. In this case, I'd let us see that while our assertion is correct, we can actually do a little bit better by further qualifying that write last should not be asserted during these frames, otherwise, or during these data transfers. We can now rerun our simulation. And we can now see that ID in this case is 1. We look for a right transaction of 1. There's the first data beat, our second, our third, and our fourth, and the last is only asserted on the last transaction. So that's a good example of how the simulation can help you improve your assertions by letting you look at the visual or look at the simulation representation. Again, here's our code that was generated, which looks rather complex, but our visual let us see what the real transaction or assertion should look like. Now we will give our assertion a name.